This week on The Futurists, Matt Miesnieks.
The thing that scares me more than anything about our future and this ambient personal intelligence around us is actually advertising. Because ultimately advertising is about creating incentives, commercial incentives to capture our attention. And as these devices get more integrated with our everything, our sensory, all our different senses, if companies are, motivated and driven to sort of capture more and more of our attention, as opposed to make our lives better, then that incentive, it scares me more than anything else.
Hey there, welcome back to The Futurists. I'm Robert Tercek. I am the co-host of this show. And this week, my partner Brett is working in Dubai, where he's spending an awful lot of time working on our next big event there, which will be coming up next year. In the meantime, I'm flying solo here today, returning to a topic I've been interested in for a number of years, which is building accurate representations of the world that we live in. If you consider what we do on computers, most of the time we're working with some sort of model, but usually it's an abstraction. If you're in a spreadsheet, you're looking at a financial model, but that doesn't tell you that much about the company. It might tell you about the financial health of a company, for instance, or project or venture, but it doesn't really give you a very good picture of what that organization looks like. And there's been a mission underway now for more than 30 years to build high-fidelity 3D representations of the world around us. However, that project has been fraught with challenges, ups and downs, sometimes big breakthroughs, sometimes big setbacks. In the meantime, the entire gaming industry, which is now more than a $300 billion business worldwide, is building very vivid 3D representations. Today, I'm excited because we have a guest on The Futurist who's been involved in every aspect of building 3D simulations of the world. And now he's working on something that I find fascinating, which is merging that 3D representation with artificial intelligence. So let's have a big warm welcome from Matt Miesnieks, who is the CEO of a new company called Primate AI. Welcome to the show. Hi, Matt. Great to see you.
Hi, thank you. Thanks for having me. This is one of my
excited to have you here because this is a topic that I would call kind of like a frontier zone for most people.
Yeah.
In the sense that there's been a tremendous amount of noise about artificial intelligence in the last 3 years. Now that ChatGPT is 3 years old and, 800 million people are using it, so it's a real thing. But even there, I think we probably both would agree that large language models are limited in certain respects. And some of the reasons they're limited is that they have a very flawed understanding of the real world. Everything you're dealing with when you're dealing with an AI of that sort, like a chatbot of that sort, is an abstraction. Yes, it's read everything on the internet. It's absorbed all the knowledge of the internet, but doesn't have any real world experience. And as a result, you see this, for instance, with video and images that are generated by AI. Often they get the physics wrong. And what that reveals to us is that there's no real understanding of the world. There's no real understanding of the physics there. This is a thing that's working as an abstraction. What someone said to me, it's like when somebody tells you a story that they've heard secondhand. That's kind of the conversation you have with an LLM. It has no real firsthand experience, so everything it tells you about is a little bit abstract because it hasn't really lived it itself. You're working to change that, though. So your vision is that we can combine AI with a really vivid representation of the 3D world that we live in. Is that right?
What we're working on now with Primate is along those lines. It's a high level of abstraction in that, I agree with you with LLMs are like a secondhand knowledge, or I kind of like to think of them as like the brain in a jar, like in a science fiction movie. They know everything, but they also know nothing about the world. And we, like people, animals, we understand the world conceptually, not with language. Yann, LeCun, the former chief of AI at Facebook, refers to as like an intuitive physics. We kind of just figure out in an abstract way how the world works. Like a baby has the concept of its mother, but it doesn't have a word for it, doesn't have a language for it. And even now, if I ask anyone to say, look, remember your mother, think about your mother, a language model, like even a video language model or an image generating language model, will give you an image like with every pixel, like the way your hair's done, everything in the background, like everything is there. But that's not how we remember. Like I remember my mum, but it's just like the idea of her, and there's nothing in the background. I don't really know what she's wearing or anything. So that is like a high level of abstraction about how the world works. And that mental model of the physical world, I think, is closer to to how biological life has learnt to navigate the physical world, and we're very interested in that problem with Primate. We called the company Primate for that reason, because it's a more of a biological type of learning
Right. So
than.
you're interested in
Yeah,
the way primates create mental constructs or mental concepts, and then you're going to see if you can build a piece of software that replicates that thought process.
very much so. Yeah, and it ties back to the 3D and the computer vision stuff I've been working on, just with that. I guess that bet that our perception is where biological intelligence started from, whether that's sight or smell or anything, and we think that's the place to start sort of unlocking an ability to understand the big physical world.
Now, how is that going to be an improvement over the current approaches to artificial intelligence?
The problem that you touched on, on the introduction, is that the world is big and messy, and you can have a language model that reads everything on the internet, and that's like, I don't know, there's 100,000, 150, couple 100,000 English words. So with a vocabulary trained on that size vocabulary, you can kind of string them together to write any poem, so write any essay, solve any businessy type problem. But when you look at what's the number of things that might happen in the world, anywhere, at any time, under any conditions, it's sort of becomes almost an infinite vocabulary of things that you'd need to train a language model on. So what that's led to today is these, vision language models or vision language action models for robots, and now some of a particular type of world model. You end up just having to throw insane amounts of data. They're getting exceptionally large. And then there isn't enough data to capture all the random things. So you've got this whole industry of simulation data to try and, simulate unusual situations. And then you come back and plug those holes with reinforcement learning as you encounter new scenarios. And you end up with this giant, expensive, heavy model that still can't handle a scenario that it's never encountered before. So our bet, and it's also what Yann LeCun has been advocating for, and many others are starting to come around to that point of view, is that LLMs are never going to solve that problem. They just it's the wrong approach, and you need a entirely new way to learn that can handle situations in the world that the model has never encountered before.
Now, I know quite a few folks who work with LLMs, and they're very bullish on this. Their feeling is LLMs can handle anything. What do you say to someone like that when you have a conversation with them? What do you propose to do that's different than what they believe they can accomplish with an LLM?
I mean, the question is more around how general do you want your model or your device, your robot, your car, whatever, to be able to handle. If you're building like I don't know, a robot to work in a factory, then that's a reasonably constrained environment, and there's a reasonably constrained number of things that might happen in that factory. And language models or generative models are going to be able to do a pretty good job within the number of things there. But when you start thinking about like a completely general purpose AI, and that could be an AI in your glasses that literally could go anywhere you go at any time, or the general purpose robots, or drones that might go anywhere. You run into that problem of there's just too many things that might happen, and ultimately, for language models to handle that, they need to be big, trillions of parameters to even
Mm-hmm.
do an okay job. The hardware is always going to be limited by battery power, basically. And so the demand for just things to work is always for smaller and smaller models. So those two tensions of LLMs needing to be really big to handle general scenarios,
Mm-hmm.
and devices needing to be low power to be able to just work all day, um, is why our bet is that LLMs are not going to be able to get there ultimately.
Okay, so you're
They'll work
talking
for a
about a
while.
completely different architecture for artificial intelligence.
Yes.
And what do you call this architecture?
Well, what? Not it's not really what we call it. The Yann LeCun's calling it JEPA, JEPA, which is itself a sort of approach, like a sub approach of energy-based models, energy-based learning, which was originally put forward by Geoffrey Hinton in the 80s. And so this JEPA isn't a specific model. It's not a product or anything. It's just like a way of learning in the way that generative AI is a way of learning. And so there'll be lots and lots of different companies built on JEPA.
I think it's probably a good idea for us to pause for a second here and note that the way a human baby learns about the world, we don't show a human baby a million pictures of a cat in various poses and say, this is a cat, and remind the baby again and again, and that's a cat, even though we're looking at the side or from the top view or something, a different angle on the cat. But that is how effectively, that's how we have to train the large language models, is we show them a million examples and we say, this is this concept, and eventually it works. I know I'm oversimplifying it, but I think it's necessary to do that. But a lot of people have begun to criticize this. First of all, that type of training is incredibly expensive. It's also very time consuming. It's slow. It is also rigid in certain ways because I think, as you just mentioned, Matt, you have to kind of anticipate all the possibilities and teach all the various versions of that concept. Otherwise, you create a kind of blind spot. So if you didn't show the side view or the bottom view of a cat, then the machine has no concept of it and won't recognize it in that context if it arises. Now, if you're using it as a chatbot, or if you're using it to generate graphics or something, that might not be so critical. But the situations you're talking about are applying this to the real world. Where machines are moving around in a warehouse, in a factory, or in some other industrial situation, or maybe even on a street. Now there's a danger because you're talking about an autonomous vehicle or an autonomous robot that could actually hurt somebody or cause some other damage if it gets it wrong. So it's critically important to get these concepts right. And the approach that you're taking, I suppose, if Geoffrey Hinton or Yann LeCun were here on the show, they would say this is more akin to the way human beings learn. We're going to try to model the training. We're going to try to imitate the way human beings learn concepts. Did I get it right? Is that a reasonable summary of
Yeah,
what you're
that's it.
working?
Yeah,
And
a good
then
way
tell me
to.
how you do that
Yeah,
kind of training, because the current approach to training large language models, at least, is to basically borrow all of the human creativity, all the output of all of humanity's
yeah,
imagination from around the world, and digest it all and use that as a starting point. Of course, that's controversial. It's hotly debated. I live in Los Angeles, where quite a few people are not very happy about the fact that their works are being
yes,
used for training without permission, consent, or any kind of payment. They don't want that necessarily. I think maybe that reaction's a little bit hysterical or overdone. Personally, I'm a little skeptical that we need to react that way. But that is a common refrain. You hear that all the time. How is your approach to training AI different from training an LLM?
very different. There's two, I guess, maybe three components to it. Like you described, like a baby, you sit there and you do watch the world. You just show it lots of short video clips, and you don't label. It's all unlabeled data. It's self-supervised learning. So what happens is it sees a cat. If there's videos of a cat there, it'll see lots of different cats from lots of different camera angles, and eventually it figures out that, oh, this thing is a thing. I don't have a word for it, but I see it from all these different angles. I kind of figure out that's the same thing every time. And so it stores that concept, as an embedding. It learns things like actions. It doesn't just learn like an object of a cat. It might learn the idea of jumping or, throwing, or these sort of time, things that happen over time. And it learns that as another concept. Again, it doesn't have words for it. And it even starts to figure out how the world works. Things like gravity. When you'll see things that are dropped, and it learns things like color consistency, like things don't change color by themselves or change shape by themselves. And even things like object permanence, in the way that if you can't see something, it doesn't mean it's gone.
Gone.
And
Yep.
that's like a baby playing peekaboo. For a while, it thinks you're gone and you're back, and you're gone and you're back, and it's really funny. And then eventually figures out that you're there the whole time, and it learns that idea. And so The JEPA approach learns all these concepts just by depending on which videos it sees. In the same way, a baby just watches the world
So
go by.
you're training the AI by showing it videos.
Yes, just
Not to
regular.
generate video. This is not a generative AI. This is so that it starts to see
Yes,
objects in 2D, really, because it's not a 3D space, but it's seeing them in two dimensions. And then, as you say, as they disappear from one side of the screen to the other, we start to get a notion that there's object permanence. That thing's not gone. It hasn't just disintegrated. It's
yes.
actually still there. It's just off screen. So you're developing that kind of consciousness.
Exactly. Yeah. And you know that distinction between understanding the world and trying to generate the world is pretty fundamental in
Now,
this approach.
I want to ask the next question because I'm sorry to interrupt you, but this is what I'm itching to ask this question,
Yeah.
which is, we don't teach a child how to navigate through the world by showing a child a lot of movies. And let me shift to a different metaphor. All these tortured metaphors. We're talking about how we train children. I'm going to throw in a different one. We can torture a new metaphor. It's a dog, because a dog never goes to school. A dog doesn't read, right? So how does a dog get a concept of the world? But a dog actually has phenomenal instincts about
Yes.
physics, right? The dog knows how the world works. The dog has a great understanding, maybe in some respects better than a human. The example I love to use is if you throw a frisbee, any dog in the world is going to be able to do differential calculus as it's running across a field. It's moving as fast as it possibly can, but it can predict the trajectory and know just how much force it needs to project itself into the air and grab that thing with its mouth, right? And so that's an extraordinary feat of calculation. We tend to think that humans and mammals have slow brains relative to computers. But what I just described there, that act of doing differential calculus while racing at high speed across a field to track a moving object, that's not trivial. Like, that's an amazing thing. That's an innate capability that animals have, right? And
Yeah.
most of the mammals that we experience in our world, they demonstrate that all the time. They have a very good, very acute understanding of the physics of the world, the permanence of objects, the shape, the way objects behave in the world. They know what's a threat. They know what is not a threat, right? And they're extraordinarily good at that. How do you get that kind of innate understanding of the world into the head of a robot?
Basically the way I just described, like by just watching things. I mean, what we're starting with is just vision. So we're just like watching the world. We're not figuring out how to act, on the world yet. That's coming later. But that sense of, watching lots of frisbees getting thrown, maybe learning how to walk, learning how to run, stumbling. What a good sort of distinction would be today. To get a robot to cross the street is pretty much an impossible job. Like a humanoid robot to cross the street, it's still kind of unsolved. But the way it would be solved today is a whole stack of different models. Like Waymo does in a car. And if there's a car coming down the street, it will look at that scene. It will try and recognize all the objects on that scene. It'll try and get 3D depth estimation of the scene. It'll track the car over multiple frames. It'll calculate the speed of the car, maybe its size, and get a sense of momentum and how quickly it might stop, and do all these like precise calculations to say, is it safe to cross the street? And that's like layers and layers and layers of artificial intelligence to try and get to that decision. You take a kid, like a 5-year-old kid, and you cross the street with it 10 times, it will not know what speed the car is going. It won't really have any concept of momentum, apart from it's done this a bunch of times. It knows roughly what happens, and it can basically say safe or not safe, with some margin of error based on, the kid's risk tolerance, I guess. But that intuitive sense of how to cross the street without knowing all of the maths and physics and depth and understanding everything in the scene is the way JEPA learns. It learns that these ideas that are abstracted away from everything in the background. So in the case of crossing the street, it would have the idea of a street, a car, roughly how quickly that car is going, maybe based on the size of it from what it's seen before, and it would know that it's safe or not. So that's a kind of that you're sort of abstracting away all of those layers that today's models have to build upon to get an intuitive sense of the world.
Now you mentioned Waymo cars. So with robot vehicles, this is a problem they've had to tackle now for a good 20 years. This is not
Yeah,
a new set of challenges. What's remarkable to me is it's working. Those Waymo cars are
yeah,
excellent. Now we finally have them in Los Angeles. I love it. When I go to San Francisco, I never take a regular cab
yeah.
anymore
Me too.
or an Uber because it's so much better in a way. In a Waymo,
Yeah,
it's funny. I hesitate to say that because I don't want to be one of these people who's promoting like robots take over the world. But it is quite remarkable. The first time when you get into one of those robot vehicles, there's a tentative moment. You're like, will this actually
yeah,
work? And the steering wheel turns by itself and so on. But it's remarkable how quickly we get accustomed to that and we immediately take it for granted. And then we
yeah,
forget about it. Then you feel very
yeah.
comfortable in the car. I think that more and more of the world is going to start to take on the characteristics of those Waymo cars, and yet I don't think most people are thinking about it that way right now. We're sort of in
No,
right now we're enthralled by the large language models and the diffusion models that are used to generate images, and those are quite amazing. But I think those are going to start to look like parlor tricks, and where you're
yeah,
going to see a lot of incredible application of real intelligence. This kind of three-dimensional intelligence is going to be in the world around us as the world starts to automate. Now, we're going to need to go to a break here. So let's hold all that. We'll come back to that conversation after the break because I really want to get into this. Like, what does
yeah.
that world of the future look like? But before we do that, there's something we like to do on the show so that our audience can get acquainted with our guests. So, Matt, I'm going to ask you a series of questions. I'd like you to give me short answers. This is what we call the lightning round.
All right.
Okay, so here we go with the lightning round. Question number one. What's your first memory of science fiction? The first thing that you remember, maybe it was a motion picture or a book that you read or a story that you were told.
Yeah, Star Wars at the movie theater in the 70s.
Right on. And tell me, is there a futurist or someone who is involved in predicting or forecasting or depicting the future who inspires you personally?
William Gibson,
Ah, great.
the author.
And tell me, is there a particular forecast or prediction that made an impression on you at some point in your career that caused you to change your career?
Not really. I've been on this same thread since my career began, so it hasn't really changed. It's this idea of bringing the near future into today.
Okay. And finally, what is one invention that you think made the greatest impact on humanity?
Uh, in my lifetime, probably the internet. Before that, plumbing. So
Indoor plumbing. Good. That's true.
yeah,
That little J bend that keeps the
yes,
smells out.
saved more lives than anything else.
Okay. Well, what a pleasure getting to know you, Matt. Folks, we're listening to The Futurists, and my guest this week is Matt Miesnieks, and we're going to talk more about 3D intelligence after this break. Stay tuned. Welcome back to The Futurist. I'm Rob Tercek, and this week I'm talking to Matt Miesnieks about 3D and artificial intelligence. Now, Matt, during the break, you and I were having a little conversation, sort of a sidebar conversation I want to catch the audience up on because there's different schools of thought here. There's different approaches. The big challenge, I guess, is to say, well, how do we create a 3D simulation of the world that we live in, one that's machine readable so that AIs can navigate through the world that we are in, or machines and robots powered by that AI could navigate in the real world. That's important for safety reasons and accuracy and business reasons, but there'll be many other applications as well, I'm sure. Now, what you were pointing out in the break is that there's different schools of thought. There's two different approaches, at least. Maybe there's many different approaches to doing this. One is simulated worlds, let's say, or fake worlds. This is what you're familiar with if you play video games. Right now there are more than 1,000 3D immersive worlds out there that are quite good. But as you pointed out, they're filled with flaws. They're not really high fidelity representations of any kind of real world. They have their own physics. Sometimes they take shortcuts. Sometimes they're limited in what they can show or the resolution that they can portray. There's another approach, and this is the approach that I think you're more interested in, which is this conceptual approach. So if you could you please clarify for us the two different approaches? Maybe talk a little bit about Fifi Lee and Yann LeCun and what they're both working on, as they both talk about world models, but it seems that they're taking very different approaches.
Yeah, yeah. So the term world model is kind of hot at the moment, but it broadly means two different things. Most of the time, when people talk about a world model today, they're referring to something that's sort of like the next step in an LLM. LLMs have gone from text to images to video to then world models, which are basically the ability to create videos, but they behave consistently with the real world physics. So there's no like weird things morphing into other things, or stuff that can't happen in the physical world.
I seem to recall a couple of years ago when Sora was in a very early stage at OpenAI. There were a number of other companies that were trying to generate video, namely Runway, Luma Labs were two of the
Yep.
leading companies at the time. And back then, what I heard about Sora, which I don't know if this is true because I haven't verified this with anyone at OpenAI, but at the time, people said, well, OpenAI has a different approach. They're trying to build a world model. In fact, that was the
Yep.
first time I heard people really engaging with that concept. And their idea was that if you throw enough data, if you do enough training with an LLM, eventually it's going to start to develop its own concept of the world that it's describing in words. That's an interesting, it's an interesting bet, but I think it is a bet, right? And I could see a lot of ways that could go wrong as well. Is that a fair description of what they're doing? I
Yeah.
don't know if that's accurate at all. And
Yeah.
I apologize to anyone from OpenAI if I got it completely wrong, but let me know. We'll have you on the show. You can correct me.
Sure. Without knowing about OpenAI specifically, that the way you described it is roughly how they're working today. They're kind of throwing enough video at it, and then like training in like all the things that a physics engine in a game engine would do, and it learns those rules, and you end up, I think, Google's Nano Banana is the state of the art, like this morning. So you can ask it to generate images or generate videos, and those objects in those videos will behave as if they're real things in the real world. So you end up with videos that are more like believable and less weird hallucinations going on. The use of the output of those systems is the more interesting question, I think. Like, you can do stuff to look at, you can maybe do things to like for entertainment and playing games and things, but how do you use them to make your life better? Like, how does a robot use this output in order to, do your dishes and stuff? So
Because it's
that
sheer fiction, right? That's completely made up. It's generated.
it's completely generated, but you can generate like lots of synthetic scenes, like lots of different
Yep.
dishes and different sinks and things, and then take all that data and
But you wouldn't use it to drive a car
model.
through a city, for instance, with other vehicles on the road.
You might use it to generate weird scenarios in cities that would be hard to catch by accident, so you explicitly.
Right.
So, but the problem is you have to kind of think about what's all the weird scenarios that it might ever encounter, and now run these world models to generate all those scenarios to then use as training, like for another model for the that drives the car. And it's complicated, it's expensive, and you'll never be able to think of every scenario. But that's kind of where world models are hyped up today, beyond just entertainment, into that simulation data.
Okay, so that's the generative approach to world models. Yes. And you're proposing a different approach. I think what you mentioned earlier is that Yann LeCun, formerly of Facebook, is proposing a different approach to a world model. Tell me about that.
Yeah. He's not the only person, but he's definitely been the most high profile and been at it for probably longer than most, and copying a lot of criticism and flack when everyone's making so much.
He's a lightning rod for that.
The other path.
I think he enjoys the controversy.
Yes. So his thinking and what we're doing too is that creatures that do exist in the physical world, people and animals and things, don't learn the world in that generative way. We learn it conceptually, like we learn the concepts of different things, but then more importantly, we learn the relationships between those concepts. Like, we learn what a dog is, but then we sort of also learn things that dogs can do and things that dogs can't do. So the relationship between dogs and different verbs, and which verbs apply to dogs and which ones don't. And then that gets more and more sophisticated and abstract, and we learn concepts like, love and kindness, and philosophical concepps about the world as our knowledge and our intelligence grows. That's definitely an unsolved problem today, but it seems to be the idea that more and more people are coming around to that if we want to get to true artificial general intelligence, we need that type of understanding of the world.
Hmm.
And so
Now
there's a
let
lot
me let
of,
me interrupt you with
yeah,
a question here. So the in the second version that you're talking about, this idea where we teach or we expose a machine intelligence to examples, and it
yeah,
begins to kind of generalize concepts from those examples. It'll identify things and say, oh, I've seen that thing before. Oh, that
yeah,
thing moves in a certain way. Oh, that thing is the thing called a dog. Oh, and here comes another one of those things. It's a different looking dog, but it's got attributes that are similar. So it starts to, kind of create a set, I guess. So it's a system of labeling. You might even say it's like a semantic system or an ontology, right? Where it's starting to develop
yeah,
a system of understanding the relationships between these different objects in the world. And the advantage of that is that you don't have to pre-train it so that you have like the full inventory. You load it up with like all of the objects that exist in that world. That's it.
exactly.
Instead, this system that you're describing can encounter something new, even if it doesn't have a word for it. It can say, okay, hey, here's a new concept. There's this object in the sky that's moving, and it moves in a straight line in the sky. It's not a bird. Wonder what that object in the sky is. And it just sort of notices it. And then over time, it'll start to develop an understanding that that's a thing called
Yeah,
an airplane or a jet, and then eventually it'll start to recognize that. So this system you're describing can actually learn from the real world, as opposed to being trained in essentially in a school. The way you train LLMs right now,
yeah,
where you spend a year training the heck out of the thing, and then release it into the world. This one could actually go out into the world and respond dynamically. To new events, encounter new concepts, start to formulate its understanding of the relationship of those concepts, and link that to interaction with other concepts that it already
exactly.
understands. Now that sounds, first of all, fascinating, but secondly, it sounds very dangerous to me, and here's why.
Yeah.
If
Oh,
you
yeah.
if you put that thing in the real world and it's moving around, it might not have a fully developed understanding of all the concepts, and it might crash into one of them.
Yeah.
Um, Tell me a little bit then, what you're doing at Primate and how that's different. And I know you've also worked in the past at 6D AI, a company where you had a successful exit to a very interesting company, Niantic, a company that's been building games at the very forefront, right at the intersection of what we're talking about, these
Yeah.
constructed worlds or generated worlds, and then the real world, and trying to create entertainment. One of the very few companies to be successful in that space. So, if you don't mind, tell us a little bit about what you've done and what you're doing in this domain, that's different from, say, Yann LeCun or Fifi Pei or some of the other folks that we talked about.
Yeah. So 6D was built on the idea that for machines to not just machines, any sort of device. We were excited about AR glasses, but it applies to robots and drones and AVs. That they needed a map of the world to learn where they are, and those maps existed for self-driving cars. They sent cars down the highways and gathered all that data, but no one was ever going to let Waymo into their living room or their place of work, and those spaces are actually the most valuable places on Earth, for us. So, how do you get maps of those places that are useful for these applications? And our insight, which certainly I think we're probably the first people to start talking about it publicly anyway, was that you needed to crowdsource that information, and you needed to use phones, the devices people have already got, and it needed to be in 3D. And that was a very difficult technical problem, but if you could solve it, you could potentially unlock this opportunity of building these maps. So that was the problem we solved at 3D, at 6D, and we had acquisition offers from every major platform at the time, but Niantic was the most attractive on multiple levels,
Hmm.
and we're acquired by Niantic. And what's been interesting since then, that was like 4 years ago now, 5 years ago, is that the vision we had for 6D is playing out exactly. Like Niantic sold off the Pokemon Go game and kept the mapping business. And then just last week, they shut down their AR web development tool, and now pretty much Niantic is a company that's sort of built on that idea that we had at 6D around building these, spatial machine-readable map of the world. And they've put that software in every Pokemon Go client, and I'm not sure what's public or not, but I know they've done some, orders of magnitude larger deal, to put it out into something, end up being something like 1 billion devices,
Mm.
for that to all come to pass. So that was really
So,
nice to
so
kind of
one of
see
the
that.
things that Niantic's been able to do with a game like Pokemon Go, their users who are, marching around the world with a phone in their hands, they have all the geoposition data from those phones, the sensors in those phones. And, the great thing about Pokemon Go is users themselves were labeling the world. So they were
Yeah,
creating the ontology of the world.
yeah,
They were the ones identifying all the monuments and important places,
exactly.
the Poke Gyms and so forth for that. So they did the work. And Niantic got the data asset. And what they got
Yes.
was a very well labeled world for that particular context. Not everything in the world, but for
Yeah.
the players of that game. But a few games later, I'm sure they had a very rich data asset. Now, what I'm hearing you say is that they're now going to transform that data asset into something that can be used by AI, or is that more the zone that you're going into next with the new
Well,
company?
I mean, everyone's excited about this same idea of how does AI understand the physical world, and Niantic has got a pretty unique data set that they've built and is getting much bigger around the physical world, and they can use that to train to different things. And I don't know what they're working on beyond the some semantic understand some sort of simple semantic understanding of the world,
Hmm.
but there's certainly we're on the same page philosophically and where the opportunity is, and I'm excited for what they do, where it goes.
Now, there's quite a few companies that are interested in this. NVIDIA, for instance, is a company that has they have a lot of resources these days,
Yeah,
and we tend to think of them as a company that makes chips, but they also make a tremendous amount of software, and that's actually one of their great advantages. The CUDA environment helps
yeah,
people build applications on top of their hardware, and that makes their hardware more valuable. But one of the areas that NVIDIA has been putting a lot of resources is in building very high fidelity 3D representations of the world. And typically this is when people outside of NVIDIA talk about this, they refer to a thing called Omniverse,
yeah,
which is, in some respects, you could call it like an operating system for a three-dimensional world. I don't know if that's accurate, but that's a loose metaphor for what they're
yeah,
building. I've heard mixed things from both sides about, some people
yeah,
are fans, other people think it's extremely expensive and over-engineered. And so it's a little bit controversial, like
yeah,
everything
yeah.
NVIDIA
You know
does.
it well. Yeah,
On my perspective is it's great that NVIDIA is out there promoting this because they have the resources and they certainly, that's one of the things their hardware does very, very well from the very early days of graphics accelerators, is building these 3D representations. So why not, of course they want to facilitate that and foster their ecosystem. Some people are concerned and they say, gosh, what NVIDIA is trying to do is build the Wintel monopoly for representations of the world where they control the chips and the operating system, and thereby they can squeeze most of the profit out of the business. What's your perspective about that? And I'm not trying to pick a fight with NVIDIA here, but I'm
no,
just I'm interested to get your view on that.
yeah. I mean, we look at it as broadly, the idea of like system one and system two thinking that we have, as humans in our brain, and very crude metaphor, but we think that system two thinking will live in the cloud, and that'll be driven by the NVIDIA type data centers, these massive LLMs, pretty much unlimited resources within the limits of the planet to deliver it. But then there's this other type of thinking that's going to live on the edge. That's our system one thinking. It's the stuff that happens in real time. It's largely based on how do we deal with the physical world and make kind of simple decisions. And then we offload the pondering, to the cloud. What I'm interested in is this edge-based AI, and I think that's going to take on over the next decade, or the next wave of AI. This edge intelligence is going to be the most exciting domain. It's the most unleveraged today, and yet there's an insane amount of compute on the edge. It's all low power. It's much more environmentally friendly for starters, and you're going to see these different types of models that can understand the physical world that are orders of magnitude smaller than anything that these giant data centers are building, but that can do a lot of the intelligence that a lot of the jobs that we're relying on cloud models to do today. So that sort of expansion on the edge and that shift of where we do our intelligence, with the sort of questions we ask, the simple things, are going to move out of the data centers onto the edge. So
Now, how will the
I don't
world
know
be
what.
different when that happens? Like, what change will I experience in the world? What new thing will be possible?
Yeah, I mean, I'll take a wild metaphor here that a friend of mine, Keiichi Matsuda, came up with, which is, think about it in terms of religion, where the open AIs and Geminis of the world, they're looking at a very monotheistic, gods that are, this is the one true God that knows everything, and that's the one we ask for everything.
Now you're scaring
And
people. People are listening to this. They're
yeah,
going,
I know, I know. That's kind of what they're trying to build. But Kichi, he's part Japanese, and he sort of looked at it through a more of a Shinto type of lens, where it says like every little thing has its own little god, and some of them are kind of helpful, some of them are annoying, some are just fun, some are powerful. There's the little god in your fridge, and the god in the stream, and the god in your car, and a lot of this edge intelligence will kind of filter out. And so, there'll be a little AI that runs in our toaster that may not talk to OpenAI. It's not going to be able to help you with your homework, but it's smart enough to make some toast. And there'll be little AIs like in all these things. Your car will be definitely smarter than your toaster, so it can maybe do more things. And it relies on its local intelligence to sort of drive the car, but plotting the route between cities, it asks the cloud god, to do that for you. So I tend to like that idea of, distributed intelligence, and all of them have sort of slightly different capabilities depending on the device. But yeah, I don't like the idea of just trying to put everything in one place, and that's the intelligence we ask to do everything.
yes, this idea of these giant cloud intelligences. I mean, it seems pretty clear to me that cloud and AI are merging, right? That's not
Yeah.
news. That's been the trend for the last 5 years. But where if you follow that trend out far enough, then that introduces kind of risks. One is extreme concentration of power in
Yeah.
an economy that depends on AI, and second one is actually a security risk because all that
Yeah.
concentration is a very attractive target for hackers as well. What you're describing is a more distributed approach, and not everything needs to be equally intelligent. In a way, I guess this is going to sound bad, but I'm guessing that it's like a little bit more of a naturalistic approach, or
Yeah.
you begin with a better understanding of how the world works. And in a way, it's a throwback to animism, this
Yeah.
idea that there's a little bit of grace in every living thing in the world. Like you said, there's
Yes.
little gods, there's a little god of the river and a little god of the tree and so forth. And
Yeah.
these little divinities, here you're talking about little intelligence divinities that might be embedded in all the objects around us.
Yeah.
How will that help people? Like, how would that help regular consuming people who buy blue jeans and sneakers and drive to work and take their kids to soccer?
Um, yeah. I mean, it does kind of get philosophical and almost spiritual, type of thing. Is that if you've got a voice in your head that you can talk to, and it gives you help, in whatever that is. That could be literally a voice that gives you some guidance to help, regulate your nervous system, or it could be advice saying, hey, the jeans are cheaper 2 doors down or something. All those types of real-time support that is there, sort of ambient in the world. I believe that if it's managed well, will be just a huge help to us.
Okay,
I th-
so if
yeah,
if one way to think of it then is these different intelligences can communicate with each other and they can update each other on situations. So, if there's like a robot or a autonomous vehicle that enters an area, all the intelligence that are there can say, hey, here's what's happening here, or here's what just transpired.
yeah,
So it kind of has instant awareness, situational awareness.
yeah,
That actually, there's a strong argument for this.
yeah,
There's a third group. We haven't talked a bit about this yet, but the Ray Kurzweil idea that humanity is going to merge with machine intelligence. When machine intelligence exceeds the ability for humans to think, we're going to start to merge
yeah.
with the computers. Now, this is a highly controversial view, and I'm not here to
I
pitch singularity and so
Yeah,
forth, but we haven't brought that up yet. The reason I'm bringing it up is that idea scares the hell out of me if those machine intelligences are dominated by 5 tech companies in Silicon
me
Valley,
too.
because it means
Yeah,
that you're going to basically opt into a feudal society. You're going to choose which
yep,
giant, mega brain to plug into, and then they're going to control all of your experiences. And I realize I'm talking about 20 years in the future or some point in the
Yeah,
future.
yeah.
This is this futuristic scenario. But what you just described, this idea of distributing a little bit of intelligence, just enough intelligence across the world to all these autonomous systems that are not all part of one giant mega brain, but rather it's lots and lots of little intelligence around the world. To me, that strikes me as a better freedom scenario, a scenario
So
whereby we're not plugging into the mega brain, and that's kind of like the Borg scenario, that
yeah,
vision that
yeah.
we're all going to plug into Google's brain or OpenAI's brain. I think a lot of people would have trepidation around that. But this version that you're describing, where there's just enough intelligence scattered around all these devices that are around us, some we see, some we don't see. But when you walk into a grocery store, or when you go to a shopping mall, or when you're driving on the street, or when you're in the airport, there'll be enough intelligence there to give your own onboard intelligence or your smart devices situational awareness to understand what's happening. They'll know who you are, so there'll be less security concerns. There'll be a better understanding of that. Now, of course, the skeptic in me jumps to the surveillance state, the idea of surveillance capitalism, where we're constantly tracked. And that's certainly true on the internet.
Yeah,
That is your experience every minute you're on the internet and every minute
yeah.
you're carrying a phone in your pocket. But it hasn't yet penetrated the real world, right? So when you're walking around the
Well,
street, if you don't have your phone, you are still somewhat autonomous and somewhat anonymous,
yeah.
or at least you have the feeling of that. This would change that. This would be a world where you're constantly tracked.
I mean, Kichi, same friend who came up with that metaphor before. He made a famous video about AR that just like I kept forgetting the name of it, but it was like everything becomes an ad in your field of view, and it was a horrific dystopian sort of warning. But the thing that scares me more than anything about our future and this ambient personal intelligence around us is actually advertising, because ultimately advertising is about creating incentives, commercial incentives to capture our attention. And as these devices get more integrated with our everything, our sensory, all our different senses, um, if companies are, motivated and driven to sort of capture more and more of our attention, as opposed to make our lives better, then that incentive it scares me more than anything else.
Mm-hmm.
I just think that's where surveillance capitalism, it's where the consolidation of power, like all of those things are sort of come down to this business model around attention capture, and that's worries me. And I wish I had here's the answer to that, but I
Okay,
don't
so
quite know
that's a
what it
scary
is.
scenario. In a way, it
Yeah,
is like that nightmare video you talked about a moment ago, and we can't recall the name of, but the idea where
yeah,
everything is a point-based economy with incentives, and as you're moving through the world,
yes,
you're on the bus and you're
yeah,
constantly scoring points and you're
literally, yeah,
accumulating,
yeah,
behavior points and so forth. In a way, I mean, kind of like a nightmare extension of Pokemon Go into our real world experience. If we're wearing
yeah.
AR goggles or some kind of eyeglasses that show us an augmented overlay, then it could be gamified. I think that's actually a very likely scenario.
It is, yeah,
If we all end up wearing AR glasses, and the reason is because the business model presents itself. Like we already know that you can incentivize behavior with those kinds
yeah,
of loyalty programs. So certainly someone's going to try that. Give me the positive scenario. Let's end the show with your positive vision for the
yeah,
world in 10 years. The work that you're doing now, how is it going to make the world better in the next 10 years?
yeah. So, I mean, just say that I don't know, like Apple's business model of you buy hardware and then they manage your privacy responsibly, and say companies like that kind of win out. I think that what's exciting is we will have this literally like a voice in our ear, in our AirPods, or a little something in our glasses that literally helps us manage our lives. Not just here's a cheaper deal down the road, but oh, I can tell you're stressed. We've talked about these scenarios before. Here's some advice to take a few deep breaths before you respond. Here's some ways just to put yourself in a better state of mind to deal with whatever's in front of you in that point, like a
Hmm.
conversation you're about to have. That that ability to, and then to do that at the edge where we're not like burning the planet to give you that information, I think is a way that we can live more, more connected, more engaged, more, more natural lives rather than getting sucked up and into the matrix and living this kind of entirely online life. And that real world being the best place to be is, I think potentially these devices, these forthcoming devices, this edge intelligence can make that happen. That's what I'm working towards.
That's cool. That's a fun vision. I'm excited to see more and learn more as you progress. So definitely we'll have you back on the show when you've got some work to show us. Best of luck to
Love
you.
that.
Where can folks find out more about your work, Matt? Where can they find you on the web?
Google my name. I'm the only Matt Miesnieks on Earth, so you'll find my social media. Primate, we're still in stealth, so we're not really sharing too much about that, but we will, and I'll announce it like on all my socials, my LinkedIn, my Twitter, my whatever it is. Wherever you find me, I'll post something. So
Super.
that's the
Well, it's
place.
been great having you on the show. Thank you for joining us on The Futurists. And folks, we'll be back next week with another person who is thinking about and shaping the future. Until then, we'll see you in the future.